Section 4.7, Law of Cosines. Solve the triangle. Here we have a triangle with side, angle, side labeled. Right now all we know is the law of sines. So if we try law of sines, we have sine of b over 15 is equal to the sine of 78 degrees over side A. The problem with this is there's two variables left, so we're not going to be able to use the law of sines to solve this. On this triangle we have side, 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 and we run into the same problem. We could have sine of angle A over 4 is equal to sine of angle C over 9. We still have two variables. We're going to need something other than law of sines to solve these. That's where law of cosines comes in. If triangle ABC, in triangle ABC, if sides with lengths A, B, and C are opposite angles with measures A, B, and C respectively, then the following are true. So we have a squared equals b squared plus c squared minus 2bc cosine of a. It's kind of like the Pythagorean theorem with a little bit added on. And even down here is really looks like Pythagorean theorem where a squared plus b squared equals c squared, but you have this little extra right here. Now these are all the same formula. It all depends on what angle you're using or what side you're trying to find. Landscaping. A triangular area of lawn has a sprinkler located at each vertex. If the sides of the lawn are 19, 24.3, and 21.8 feet, what angle of sweep should each sprinkler be set to cover? We have a triangle here, and let's make this 19. That makes this angle A. And then B is 24.3. So we'll make this angle B, and then over here we have 21.8. That makes this angle C. We can pick any angle we want. Maybe we pick angle A. We have 19 squared is equal to 21.8 squared plus 24.3 squared minus 2 times 21.8 times 24.3 and then cosine of angle A. On our calculator, we're going to do 19 squared, and then we can minus the 21.8 squared, and we can minus the 24.3 squared. That cuts these off. That takes care of those two, and we'll divide by this. So we divide by negative 2 times 21.8 times 24.3, but we need that in parentheses. Let me put parentheses over here. Insert parentheses. Enter. Now that is the value of cosine, and we need to take the inverse cosine of this answer. Inverse cosine. This is going to give me the angle, but my mode is it is in degrees. Good. It's in degrees. We press enter. 48.305. So angle A is 48.305 degrees. Let's find another angle. Let's find maybe angle B this time. So 24.3 squared is equal to 21.8 squared plus 19 squared minus 2 times 21.8 times 19, and then cosine of, I used 24.3, so we're finding angle B. 24.3 minus, actually we got to square that. So squared minus 21.8 minus squared again, I'll remember, and then minus 19 squared. We get that answer, and we have to divide by negative 2, forgot parentheses again, here we go. Negative 2 times 21.8 times 19. Now that is the value of cosine of B, so let's take the inverse cosine of the answer, and that's going to give us the angle. 72.743. Angle B is 72.743. Let's add on the 48.305, and then we'll minus that from 180. So 180 minus the answer, and we get for angle C, That's equal to 58.952 degrees. And this is degrees also. Apply the law of cosine. Solve the triangle. Round side lengths to the nearest tenth and angle measures to the nearest degree. Let's solve for a here. We have a squared is equal to 14 squared plus 12 squared minus 2 times 14 times 12, and then that'll be the cosine of 39.4. This one's nice because you can just go right down the line, and we'll have to square root in the end. We have 14 squared plus 12 squared, and then minus 2 times 14 times 12, and then times the cosine of 39.4. And then we need the square root of that answer. So square root of answer, and side A turns out to be 8.964. So let's get angle A, angle B, angle C. And we have side A, side B, and side C. And we found out side A is 8.964. We know that C is 14, and we know B is 12. We also know angle A is 39.4. Now that we've found this answer right here, I'm going to store this. Let's store this in letter A, so alpha A. That's side A. Now we have sine of 39.4 over what I put in A in the calculator is equal to the sine of B over 12. We have sine of 39.4 times 12, and then we're going to divide that by alpha A. Now that's the value of sine of B, so we take inverse sine of the answer. And we get 58.175. This is 58.175, and we'll add 39.4, add 39.4 to this, and subtract that from 180. So we have 180 minus the answer. 82.425. So this is 82.425 degrees. Heron's formula. If the measures of the sides of ABC are A, B, and C, then the area of the triangle is the square root of the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B, and then semi-perimeter minus C, where the semi-perimeter is half the perimeter. So you add up the sides, divide that by 2, that's the semi-perimeter. Find the area of triangle ABC to the nearest tenth. So the nearest tenth, we have the area is equal to, we can start the square root, but we need the semi-perimeter. So let's take 44 plus 47, and then plus 53, and we'll divide that by 2. So the semi-perimeter is 72, so the area is 72 times 72 minus 44 times 72 minus 53, and then 72 minus 47. That's the square root of all of that. So now it's just plug and chug. So we have square root of 72 times 72 minus 44 times 72 minus 53, and then finally times 72 minus 47. And the area of the triangle is 978.570, and that's going to be feet squared. Area of a triangle given side angle side. The area of a triangle is 1/2 the product of the lengths of the two sides and the sine of their included angle. So the area is 1/2 BC sine of A, or 1/2 AC sine of B. This would be the angle, and these two sides are the included sides that make up that angle. So if you have angle A right here, it's made up of side B and side C. So here's another formula for area. Find the area of triangle ABC to the nearest tenth. So the area is equal to we have 1/2 of 39 times 52, and then times the sine of 25.89. 0.5 times 39 times 52, and then times, we get the sine of 25.89. And the answer is 442.7, to the nearest tenth. So that'd be actually 0.8, and then we have inches squared. The triangle has an area of 36 centimeters squared, and two of the sides of a triangle have lengths of 7 centimeters and 12 centimeters. Find the angle included by these two sides. So let's draw a triangle. And we're told that the whole area is 36. So 36 is the area. That'll be 1/2. And then if this side is 7 and this side is 12, they want the included angle right there. So 1/2 times 7 times 12, and then sine times just whatever the angle is, sine of theta. 6 times 2, that takes care of the 1/2. And then divided by 84, which is 7 times 12. And then we take the inverse sine of that answer right there. And the included angle is 58.997 degrees.